We're going to try an example number two, a little more complicated question. In this case, I have this boy and he is on his skateboard. I know his mass and his initial velocity, and he's going to go up this hill. I want to know at point two how fast he's going at this point. Obviously, it's going to be less than 8 meters per second, but it's going to be smaller. And then how high is the maximum height? Now, remember at the maximum height up here, this is where he's going to stop before he comes back down the hill. So he'll actually have no velocity up there. So to do this question, this is where most people go wrong is they forget about point one. Point one is there for a reason. Point one is where I'm going to find out my total energy. I need to know what is the total energy of the system before I can do anything. And the total energy he has at point one is the only kind of energy he has is kinetic. He only has kinetic energy. He's not up a hill or anything yet. He's only kinetic energy. So I can find that very easily. I can just substitute in my numbers, put in my equation first, because I'm going to use 1/2 mv squared as my kinetic energy. I know his mass. They tell me that. I know his velocity. I'm going to square that, and that will let me find my total energy. I need to find the total energy every time. Most people get this confused. This is where people go wrong. And it's not that hard once you get used to it, but you always have to find your total energy. That will give you all the information you need for one spot so you can do that. So I got 1,920 joules. That's my total energy in this system. That total energy then is going to be distributed differently. When I get to point two, at point two, I will have the student now 1 meter off the ground, but he's not at his maximum height yet. That means it has both kinetic energy, because he's still going to be moving at this point, and gravitational energy. He'll have both, but both of those still have to add up to the same total. Energy cannot be created or destroyed. It must come from somewhere. So the total energy will still only be 1,920. It's just that part of it is now going to be due to his velocity, and part of it is going to be due to his height. Now I can substitute everything in here except for that velocity I'm looking for, because I know the mass of this boy. They told me that. I'm trying to find his velocity at point one. I know his mass, I know 9.8, and it says on the diagram he is 1 meter high. So this will let me find my value. And once I have that value, then I can find his velocity, right? His velocity is going to be very easy. So I'm going to divide by my, and then don't forget, you're going to have to take the square root, right? Because it's v squared, and I get 6.7 as my velocity. Now, how many steps you need to solve this is up to you. Remember, I'm a big believer that you should write down whatever steps you need. But when it comes to significant digits, I only get two because of the 60 and the 9.8 and the 1. So two significant digits, and it would be meters per second. Okay, our last part of our question asks us to find the maximum height. How high does he go at point three? Now, at point three, he's not going to have any different amount of energy. He still has a total energy of 1,920 joules. It's just now at the top, he's not moving anymore. He's about to come back down. So that whole 1,920 has turned into gravitational energy. It's just changed types of energy. So I can now find how high that is, because all of his energy that he had at the start, that energy that he had that was a mix of energies, has totally become gravitational energy. That means he rises. And again, I only get two significant digits because of the 9.8 and the 60. So I get 3.3, and it should be meters because that's the base units. All I need is my therefore sentence.